I like to discuss my thought process on course schedule 2. So course schedule, there are a series of problems. Course schedule 1, course schedule 2, and there are also course schedule 3. Course schedule 1 and 2 are closely related. It's about topological sort. So topological sort, it's directed acyclic graph. Its functionalities actually is to also detect cycles. That's its functionalities. There are two approaches, both work. One is called the Kahn's algorithm, which we use BFS and in-degree list. The other approach is the DFS, post-order approach, but after that we have to reverse it. When I was first exposed to this, I find the DFS approach a little bit confusing because we do have to keep track of visited set. So I prefer the Kahn's algorithm. So let's go into this problem. It's basically talking about I want to complete, for example, I want to complete all the courses to graduate college. Some courses have to be taken. So for example, some course, you can start taking it in freshman year. You don't need any prerequisite. But as you advance, some courses require prerequisites, and you need to complete the prerequisite to take the actual class. And we also have co-requisite. So let's look at it here, for example. It's given to us that A and B are unique. You don't have cycles, I believe. I think it did say that somewhere in the problem, that is guaranteed. That is, they're distinct. So assume we have the easy case. So you have this prerequisite and this actual course. And here you can construct a graph here. So you have, like, as a freshman, you need to take course 0 first before you want to take, for example, English and Spanish concurrently before you move on to, say, English 300. And what we notice here, you can see that a 0 has no degree, no arrows pointing to it. So it has an in degree, means like any in degree pointing to it is in degree, has 0. 1 and 2 has 1 in degree and 1 in degree respectively, and 3 has 2 because 1 and 2 are both pointing to it. We can think of as like peeling off layer by layer. So we can definitely start taking course 0 first, right? After complete course 0, we can take this out. So then it becomes, we can start taking 1 and 2. And because 0 is already taken, their in degree gets decremented. So both 1 and 2 are ready. We can start taking courses whose in degrees are 0, right? So take 1 and 2. It doesn't matter the order here. And then when we finish that, they're gone. 3's in degree becomes 0 now because 1 and 2 are gone. And we'll complete 3 and we're done with the courses. Just like here, the result, say, it can be 0, 1, 2, 3 or 0, 2, 1, 3. However, if we did all the courses, but the last course requires something else, we cannot complete this course. So in that case, we will return empty. Here I would like to use default dict because I like to use my key and map to a list of classes. I'll use that, and then also deck for the DFS because I can pop from the front. So here I would import my 2 libraries. So here, so from collections, import default dict and deck. So number 1, we are going to pre-process our data. Right? We gotta build our dictionary and build our in degree. So in degree is basically tracking the in degree for each course, including the lower courses. Initial value is 0. Assume that I can start taking any courses right away. And number of courses, the number of courses we have. So the purpose is to track in degree. And dictionary here is going to be default dict. It's going to be a list. So here, the key is the lower course or the prereq. And it's mapped to a list of higher courses. For example, in this problem, 0 is the lowest course, or we can start taking right away. And its higher courses are 1, 2. Okay, so initialize these, and we use a for loop. There's a tuple, 2 elements in there, in prerequisites. Okay, and because I want to complete all the courses, so basically it's querying from lower to higher. So lower will be my key. I'm gonna find the list of the higher courses, and also in degree of this higher, because now we have like an incoming course that needs to be completed before the higher course gets completed. So its in degree goes up. So the purpose of this is to construct the dictionary, also the in degree. So now I will have a deck. It's a BFS part. We're gonna check each course. So I here represents the actual course number, because the course goes from 0 to course minus 1, right? So this means like for each course, in range length of num courses here, right? We're going to check, can we kick things off, like start taking courses? So if the in degree of this current course is 0, means I can start taking it right away. I'm gonna queue it to my deck, means I can start taking it. Okay, and this is my result. I'm gonna store my result here. So while my deck is not empty, I can start taking the course. So pop left. Anything that's in my deck, already here, anything in my deck means course, means this course can be taken right now. Okay, so because this course, I can do it right now, I can complete it right now, I will append this course. And result is what we want to return, right? But because this course is taken now, I have to see its immediate neighbors if they are being affected. So for example, if we come back here, if 0 is already taken, then I have to start looking at its neighbor. And because 0 is taken, their in degree has to be decremented, right? So for higher in this course, since it's a key to a list of higher courses, I am going to decrement the in degree of this higher, since now that this course has been taken, its in degree is decremented. So after I decrement it, then I do one more check. If in degree of this higher is 0 now, means this higher course can now be queued and to be completed. Okay? When this is all done, if I did all the courses, then it should equal to the num of courses. I will return result. Otherwise, I will return empty. So for example, I need to complete 4 prerequisite, but I only completed 3. And for example, I don't know what happened to the other one. Assume that there's no cycle, then I cannot complete the last one. So I will miss a course. So the length of result will not equal to num of courses, and I will return empty list. Okay, let's try and see if it works. Okay, append. And here is, okay, so it's the length of in degree, or it can just be number of courses. So submit it. Time and space complexity is actually the number of nodes plus the vertices, or the number of nodes plus edges, number of courses and its prerequisites, and so is space. Thank you.